All right, so I want to start out with finding the trig function of any angle, okay? So get this diagram down. So let me make sure that you understand which angle it is that I'm talking about, because I couldn't, for some reason, get the notation in there. Okay, I know. Shut up. Okay, so here's your x and y axis. So that's x, that's y, and the angle I'm talking about is this angle here. That's theta. Okay, that's theta, and this point here is x comma y. Okay, everybody got that? So these three formulas that you see here for sine, cosine, and tangent are really important. Okay, what is that? Okay, the other concept you got to remember as well is what I call quadrantal angles. Okay, quadrantal angles. So what I mean by that is that if you look at the xy axis, okay, you can get a point here, and let's say it's a point on a unit. Let's just say it's there, it's there, it's there, and it's there. So the angle that this point corresponds to is 0 degrees. That's this angle here, okay? The angle that this point corresponds to is that angle? 90 or pi over 2 radians, okay? Pi over 2. And then this angle here, which would be going all the way around like that. 180 or pi. And then finally this angle here that comes around like that. That angle would be 270 or 3 pi over 2. So these are called quadrantal angles because they're at the borders of every quadrant, right? Like this is at the border of Q1 and Q4. This is at the border of 1 and 2 and so on. That's why they're called quadrantal angles. Well, what's really more important about these angles is to know their trig values. To know the trig values. So for example, sine goes with which coordinate? Which coordinate does sine go with? Y. What's the y coordinate of that point? 0. Cosine of 0 degrees, cosine goes with what coordinate? Sorry, x. And if this is on a unit circle, then this would be 1. Right? You guys with me on this? Beta, you look kind of zonked. You there? And then tangent, you know tangent is sine over cosine, right? So tangent 0 would be 0 over 1, which is 1. Okay? So I want you to make a list like this. Sorry? Oh, 0, 1, no. And this is recorded. Oh my God, I'm in trouble. You know, that's the disadvantage of getting this recorded. It gets into administration's end, man. This guy's an idiot. I'm going to fire him. Oh my God. Okay, you guys need to...
It's still recording.
Oh, you guys need to make a table. You guys need to make a table like this for 90, 180, 270. Okay, you guys with me on that? Calculus stuff in there. Okay. So again, like I'm saying, that this is really a review. It's something that I covered in I forget 4.2 or 4.3. Okay. So this should really be a review. And this is very similar to the previous slide, except that I put in all students take calculus in there. Okay, all students take calculus in there. So one more time, I guess the diagram doesn't show what theta really is and what theta prime really are because I couldn't draw an arc in this. So what I'm talking about is, here's your y-axis, x-axis, that's x and y there. Here's your terminal side of an angle, So theta is this angle here. That's theta. Okay? All right? And then this is theta prime. Okay? Theta prime. That's the reference angle. So this is reference angle. All right?
You're really fast on iPad. Yeah.
What? Yeah, well, yesterday I didn't have any work to do, so I just graded. Just graded.
Like my 6th period is already at.
Yeah, I still have to do 6th period though. Okay, here's the formal definition of reference angle, okay? Here's a formal definition of reference angle. So notice that it is a positive angle, and it's an acute angle that the terminal side makes with the x-axis, okay? Makes with the x. To you, okay? Why do you need reference angles if you want to calculate, for example, the sine of 240, okay? Say you want to calculate the sine of 240 and no calculators, okay? No calculators. Right? So what you want to do is, first of all, let's go draw that diagram down. To 240, what quadrant? Third quadrant. So that's 240 degrees. Everybody with me on that? Okay. All students take calculus. Yeah. What's the ref angle? 60 degrees. So sine 240. Is it going to be positive or negative in that quadrant? Negative. And what's the sign of the reference angle? So this comes out of your friend's table. Nice, beta. Your answer is negative root 3 over 2. Okay, so do you see how I use reference angles and all students take calculus and friend's table? Okay, so everything really comes out of there. Okay. So to me, this is an alternative to the unit circle. Okay. So now what I want you to do is, since you know friend's table, you know all students take calculus, and you know ref angle, I want you to fill in this table here. Oh, well, some BIT, oops, my bad. I'll do it. That was being recorded. Oh my God, I'm in trouble. Sorry? Yeah, but you know how long I spend doing these things and how many people actually look at it? Let me just pause this and I'll give you a lecture. Work on this problem here. Okay. But you know the new ones? I think what the new ones are, you can actually monitor it yourself. So in other words, they can be upstreaming video to you directly. So you don't have to sign up with someone. You are your own watchdog. So you've got iPhone, something's happening. Yeah, so I mean, it's got pretty high-tech stuff. Okay, so let's work on this problem here, okay? So given the point 6, negative 14. Yeah. Yeah. So 6, negative 14 would be, say, somewhere out here. Okay? Is everybody with me on that? That's negative 14, okay? So your angle would be this angle here.